The last concept we want to talk about in this section is the concept of static fields and methods. You have seen the static keyword throughout this course, but what is it all about? Well, in object-oriented programming, a class can have two types of members: instance members and static members. Instance members belong to instances or objects. For example, in our employee class, all the members that we have declared here, like these fields, and all these methods are instance members. They belong to each instance of the employee class. So when we create an employee object, we can access these members using the dot operator. So these are the instance members, right? In contrast, we have static or class members. These are the fields and methods that belong to a class, not an object. So here, if we type the name of our employee class and use the dot operator, we don't see anything because this class doesn't have any static fields or methods. Now, you might ask, what is the purpose of these static members? When do we use them? We use them in situations where we want to represent a concept that should be in a single place, like the number of employees. This concept does not belong to each individual employee. So this is where we use static members. Now let me show you how to use these static members. So back to our employee class, after we declare our instance field, we declare static fields. So we type public static integer number of employees. Now, here in our constructor, every time we create a new employee object, you want to increment the number of employees. So we type number of employees plus plus. Now back to our main class. Here we're creating an employee object, so we should have one instance in the memory. To prove that, let's print this field on the terminal. So print line employee dot number of employees. So as you can see, with these static fields, we don't have to create an object. We access them directly through the class. Let's take a look. So we run this program, and currently we have one employee object in memory. So we use static fields in situations where a value is independent of objects, and we want to share it across all objects. Now we can also create static methods. For example, back to our employee class, after our constructors, I'm going to declare a static method. So public static void print number of employees. Here we simply do a print line and print the value of our static field. Now back to our main class, we can replace this statement by a call to employee dot print number of employees. So now our employee class has two static members, one field and one method. Now, one thing you need to know about these static methods is that they can only see the other static methods in this class. So here in this static method, even though we are inside the employee class, we cannot access the calculate wage method because this method belongs to an employee object. It's an instance method. So we have to create an employee object, and then we'll be able to access this method. That's something you need to remember. That's the reason why in the first part of this series, all the methods that I added to our main class, I declared them as static. So we could call them from the main method. Now you might be wondering why the main method is declared as static. This is to enable the Java runtime to directly call this method without having to create a new object. So that's why the main method is always declared as static. Also, as another example, this system class that we have here has a bunch of static members. Out is one of its static fields. Here's another example, integer.parseInt. We talked about this in the first part of the series. This is another example of a static method in Java. As you write more Java code, you will see that many of the classes in Java library have static members. So this is all about static fields and methods.